in this part, will have a brief look into distributed systems. So distributed systems are just collection of computer nodes, and these systems, these computer nodes are connected by a common network. Okay? And there is a software that manages these set of computers that are connected. And most of the times, like we use distributed systems to achieve a common goal where all the nodes that are part of a distributed system are working to achieve certain goal. Okay, the goal could be processing some messages or handling certain web services, so on and so forth. Okay? And the nodes inside a distributed system, they usually communicate with each other through the network, right? Most common mechanism is message passing. So examples of distributed systems, as you can imagine, like any system that you use now, that we use now is a distributed system. Like the Google services that we use, Google Drive, that's a distributed system. Like Amazon AWS, it's a distributed system. Hadoop, MapReduce, anything, any cloud scale system that we use is a distributed system. And for instance, any website that we use now is a distributed system in itself. So, and there are many distributed systems that we use, and there are many services that are provided in a distributed manner. And one of the service that we are interested in this lecture is file systems. So the file system itself can be provided in a distributed manner, which we call a distributed file system. So the key difference from centralized systems compared to distributed systems are, like, unlike centralized systems, the memory, or like there is no physically shared memory. That means uh, the nodes or the processes that are running in a distributed system need not have the same physical memory shared. Okay, and unlike centralized systems, the communication is unreliable. So there could be some delays when when you want to communicate with other nodes. There will be delays in distributed systems, and there is no common clock. So that means now synchronization becomes hard, especially synchronization with respect to time becomes very hard because the time could be different on different nodes. Right? And distributed systems needs to take care of failures, like the computer nodes that are part of a system might fail. So we should have a mechanism to recover. Our distributed system should somehow know that a node failed and it should recover from that failure. Okay. And the hardware and software that runs on each machine that is part of a distributed system could be different. Right? For instance, we can have a Windows machine that is part of a distributed system, and similarly we can have a Linux machine. Like we can have multiple Linux and multiple Windows machines that are part of the same distributed system. So a distributed system should take care of these heterogeneity of different operating systems, and even the hardware that runs on each computer node could be different. And when we have distributed systems, along with the other complexities, the complexity of the corresponding operating system also increases. For instance, now the synchronization is no more the simple, like synchronization that we saw, like using mutex and semaphores, lock and wait, that is supported by a single processor. That that's not going to work in distributed systems, right? And similarly, deadlock detection, the very nice resource allocation graph that we saw will not work because now we don't know what are the resource configurations on different computer nodes. Similarly, managing physical memory also becomes hard because now the physical memory is shared across multiple computer nodes. And similarly, file system is also hard. We will look into like what it means by distributed file systems in a couple of slides. But like, yeah, file systems is also becomes tricky. And along with the other complexities in the OS design, there are other new issues depending on the type of distributed system. In few cases, a distributed system may need to select a node as their leader. So this is a problem of distributed agreement. So there are many algorithms that are proposed to select this, to come to an agreement. And similarly, there are many failure recovery modes. And similarly, there are also cases called Byzantine failure, where we have, let's say we have a group of nodes in which one of the node is malicious. So how can you detect, like how can you get to a consensus to identify a malicious node, right? So there are various other interesting problems that happens in distributed systems, along with making the regular problems complex. Like there are new problems that occur in distributed systems. Uh, in this part, we will have a brief introduction of distributed file system. So in simple words, a distributed file system is a file system where it provides an abstraction of a file system where the underlying disks are actually scattered across multiple nodes in the network. Okay, so here, as you can see, the disk that is actually storing the data these disks are present on different machines in the network. Like the server could have multiple disks. Similarly, if there are 3 clients, each client has a disk. So all of these disks are serving a single file system. Okay? This is the distributed file system. And like they provide, like the interface provided by the distributed file system is as if all the files are located in a single disk. Like there is a single logical disk, whereas in reality, this logical disk is split into multiple physical disks that are stored, that are present on on different computer nodes, which are connected through network. So distributed file system should take care of managing all these disks that are spread across different computer nodes in the network. So examples of distributed file system is like NFS, like network file system, which we will be looking into more detail in the next class. So there are many ways in which a distributed system can be organized. So for our discussion of distributed file systems, client server model is the classic method that is used to implement this distributed file system. So in client server model, like the other model is decentralized model where like that where that model of distributed system is different. So DFS uses client server model of distributed systems, where there are 3 main components in client server model. Okay. First, service. So service is just a software that is running on either one or more machines, and it provides a particular type of function that can be used by any client in the system. So the clients that are using is unknown. So uh, there are no a priori known clients. The service just provides a functionality. Okay, it's a common functionality that any client can use, and the server is a machine that runs the service. Okay, and client is any computer node or any process that can invoke the service to achieve the functionality, to access its functionality, right? And the functionality that is exposed by a service to a client is called client interface. So this that means like the client can see service through the client interface. So service could expose multiple functionalities, but only the functionalities that are part of client interface are the ones that are visible to a client. So distributed file systems, actually we use it. So when you log in onto ECN Grid, you'll always see your home directory always mounted, right? So that is actually a distributed system that's that we actually use. Okay? And you can also realize that sometimes it's very slow. And I think a couple of days ago, there was an error where like you lost your files on temp files in temp folder. Uh, so again, that shows an error in like the problems in distributed file systems. And so formally, a distributed file system or DFS is an implementation. It's like a time sharing model of the classic file system. Okay, so we can like with respect to similar operating system analogy, we can consider a file system as a batch processing system, like the initial operating system. Now, distributed file system is a time sharing model of a file system. Okay. So where here multiple users share files and the storage resources, which are spread across different computer nodes in the network. And there are many distributed file systems that have been proposed and developed and which are optimized for different use cases. Like if you just Google distributed file systems, there are multiple file systems. And each of these file systems are actually optimized for a particular use case. So why we need distributed file systems is because there are four main advantages, right? One, it, it allows transparent access from multiple clients. So same user on different machines could see the same data. And the sharing becomes very simple. Now, if multiple users want to share some data, they can always put a file onto common location and all the users who access that location will see the same data. So sharing becomes really, really easy. And similarly, administration also becomes easier because we just have a single service or like server to maintain. So we don't need to maintain individual machines. If we have to make changes to the file system, we just need to make changes to the service. And also we can add reliability by adding RAID to the storage server, right? So however, also however, distributed file system provides nice advantages. It has various challenges. First, it needs to provide transparent access where irrespective of the location of the file, the naming or like given a name, irrespective of the location, users should be able to see the file. Irrespective of the computer node from which user logins, by just using the name, user should be able to access the file. And the performance should be scalable in the sense like adding more clients should not degrade the performance. And there should be at least small amount of fault tolerance. So if one of the client or server dies, uh, we should have a way to recover from that fault. And eventually we should have consistency. That means like if the same file should appear on different machines. So it should not be the case that if I access file foo on machine one, the content is different if I access the same file from different machine. That should not be the case. The contents of the file should be consistent, or like similarly directory structure could be consistent. Also the security should there should be security of the file system, right? So we should make sure that the authorized users can access the files. And the file system permissions also becomes tricky now because these permissions needs to be now enforced among the files that are stored on potentially different machines. Okay. And as is the case with all the other operating system design principles that we have seen, these goals are conflicting. For instance, in order to get performance, caching definitely helps, but it hurts consistency because if you cache a directory structure on one computer node, on one, let's say if you have page caching on one system and if you cache the directory entry in the page cache, but if the directory changes on different, is changed by some other user on different machine, now the page cache needs to be updated. So, but that's not easy, right? So now the page cache needs to be synchronized across multiple machines. So it hurts the consistency, maintaining consistency in presence of caching becomes hard. So there is a tension across these goals. In the next class, we will look into one of the most commonly used distributed file system called NFS, Network File System. Okay. Thank you.